Hey, fellas.
Welcome back, guys.
See you, How y'all doing, man? Good to see you, man.
While we were waiting for the casing of Borehole 1 to get done in the Mesa, we welcomed back the guys from Lock Precision to help us conduct our most advanced rocket experiment yet to figure out one of the craziest anomalies we've ever encountered on Skinwalker Ranch.
You know, we've been following up on what appears from our view through LiDAR to be an invisible bubble that is about 600 meters in radius, centered on the triangle here.
Based on numerous infrared LiDAR scans, a gigantic sphere that we call the bubble sits above and below ground, and it covers a huge area, including the Mesa drill site, the East Field, and even Dry Gulch Creek. It's like something that we can't see exists all through that zone and displaces or swallows the data. So today, we're going to use high-powered rockets equipped with specialized devices to see if we can collect some accurate data up in that space. All right, everybody ready for launch? In 5, 4, 3, 2, 1. Rocket straight overhead. I don't see the light. There it is.
I saw the chute charge, but I didn't see any lights.
I think I just heard it crash on the ground.
Hey, Travis,
Yo,
you're not gonna believe it.
what am I not gonna believe?
So I get over Dry Gulch Creek.
South of it.
Yeah. When I get up near that barrier of the bubble, I start losing all communication on the drone. Could not move the drone.
So that you had GPS errors, you had communication errors.
Yeah.
That's crazy, man.
Hey, Travis, this is Pete. You want to walk over here to the terrestrial laser scanner?
I'm headed right there. Jim's drone issues sounded like, once again, the barrier of the bubble was somehow stopping us from collecting data. So that made me wonder what Pete was about to show me on the LiDAR scanner that we had right in the center of the triangle. What's up, Pete?
Just look at it
What do you want me to look at?
and tell us what you see.
All right.
There's where the rocket was launched from.
Right.
But way over here is where the LiDAR shows its smoke trail after the launch. They should line up.
The rocket is displaced by
10, 12 feet?
10 or 12 feet.
That makes no sense.
LiDAR technology uses infrared light to map out detailed images of an environment. But once again, something at the center of the triangle either fooled or displaced Pete Kelsey's terrestrial LiDAR data to make it seem like our last rocket launch was several feet away from where we knew it actually was. This was more possible evidence that something right in the center of the bubble is corrupting our data collection. But what on earth could do that? Eric, we're a couple of minutes from launch.
Copy that.
How we doing out there, guys?
Good. Well, ready to arm it all up here. Okay. Let me check Kate. Okay.
Either way, now that something at the center of the bubble seemed to be once again stopping us from collecting data there, we needed to launch that last big rocket to see if we could figure it out. All right, let's do it. Hey guys, don't forget to start all the lights and everything. You can trim that down. We got something on the mesa. Eric, we got something on the mesa just west of the tower. Eric, if you got any eyes on top of the mesa that can look north just over the mesa behind the launch tower.
I am watching now.
Travis, please be advised, I do show a moving point of light.
That is to the north and west of the triangle.
Quite interestingly, Travis reports spotting a prospective UAP over the mesa. Immediately, my thoughts are turned to the very peculiar timing of when it showed up. This happens to coincide with the emergence of a 1.2 gigahertz signal. We don't know where it's coming from, but I would really like to know, and I think we would all like to know, what relationship there is between these emergent signals and some of the other phenomenology, like the UAPs that we sometimes see.
Kate says launch is a go.
All right. 5, 4,
3, 2, 1.
Ooh,
chute has deployed. We see the rocket straight up.
Travis, do we have
Eyes on the strobe.
Yes, we do, Eric. It is straight up.
copy that?
2,400 feet right now, Eric.
Copy you, Travis.
I've got eyes on the rocket.
This one's falling way off course. Y'all see that?
Kind of whipping around up there a little bit.
How far?
Half a mile.
Half a mile away right
It's
now.
going to the
north.
same place.
Yeah. These huge rockets are designed to go straight up and come straight back down. There were no high winds, but both large rockets fell way off course to the same spot, like something pushed them away from the bubble. Again, it was like something was stopping us from collecting data above the triangle and inside the bubble. So what could do that?
Hey guys.
Hey.
Come on in, have a seat.
What's going on?
We are going to look at the data from the rocket launches with Locke.
That was a very active night. Remember, there's just a lot going on.
After spending most of the next day crunching all the data from our rocket experiment, Eric called us into the command center to review everything.
So what I'm going to show us is the positional GPS data for all the events that go along with rocket launches.
So, this is the Kate data then?
Yeah.
Which was the computer inside of the rocket.
Yeah. Watch this. So you're going to see the launch. We are at the triangle, center of our bubble, and look what happens here.
Wow.
Oh, wow.
That's crazy.
Yeah, so, I mean, look, you guys were standing right down there at the tent. You saw this launch. Do we all agree it didn't do this?
Yeah, it did not do
It
that.
went straight.
Nevertheless, according to a very sophisticated rocket tracking system, that's the path that rocket took. There's an abrupt change of direction.
That rocket did not do that.
Now look at this. Green coloration means that we have a stronger link between the Kate system aboard the rocket and the receiver on the ground. The red end is as weak as it gets.
But so what that means is the Kate system was affected by whatever this phenomenon is.
Yeah.
Yeah.
We all saw that rocket go straight up above the triangle. But according to the Kate GPS tracking system, right after the rocket was launched, it flew at a very hard angle for several hundred feet before suddenly turning and then going straight up. So could the bubble have fooled this rocket's GPS tracker to think it made these maneuvers? Now, the weird thing is, zoom out all the way to the, so we got the whole thing. And let's see if there are other kinks in the flight.
Yeah, let's have a look.
I would say that this part here, that looks like regular rocket trajectory. Right here, there's clearly a kink, and it's possible that somewhere in here, we've got missing data here, and you've got missing data here, and missing data here, and here. Inside the bubble, right? We've consistently seen missing data inside the bubble. But then look up here, there's more missing data. Somewhere in here, right? That's about 3,200 feet. That's where the rockets got pushed off course on their descent. Look, we got rocket data missing above the bubble at about 3,200 feet high. So now we got something else going on above the bubble too.
It's pretty damn interesting.
That's real interesting. There's a gap of missing data points about 3,200 feet high above the triangle, right where the rockets fell off course. So is there another anomaly above the bubble that is related to the countless UAPs, strange signals, and voids in our data? And if so, how are these things connected?
Okay.
Thanks, guys.
A lot of our efforts are focused on judging whether we're dealing with something real or simply artifactual within our data when we're talking about this bubble. We need to employ everything we've gotten to give us even more accurate data to find out.
Between the UAPs, the repeated missing data, and the weird signals we detected this week, it feels like something on Skinwalker Ranch is trying to discourage our investigation. Well, let me tell you, it's all having the opposite effect. And we're not going to give up until we have all the answers.